You're watching the One-Eyed Monkey channel, where tech, gadgets, and Bitcoin collide. Okay, let's be real. When you think of Bitcoin mining, you probably think of one thing: a massive appetite for energy. It's the story we've all heard a million times. But what if I told you that entire narrative could be flipped on its head?
Yeah, you heard that right. The big question we're tackling today is a wild one. Could the very thing that gets so much heat for straining our power grids actually be the key to making them more stable? It sounds completely backward, doesn't it? But there's a fascinating technical argument here. So how on earth could this possibly work? All right, so before we can really get into the solution, we have to understand the problem. And the problem, ironically, starts with something we all want: more renewable energy. It's a fantastic goal, but for the folks who have to keep our lights on 24/7, it's a huge headache. And the key term you gotta know is variable renewable energy, or VRE. Basically, we're talking about solar and wind. Unlike a good old-fashioned power plant, you can't just call up the sun and ask it to shine a little brighter because everyone's getting home from work. This on-again, off-again nature of VREs creates a massive balancing act for the grid.
And this is what that chaos looks like. It's famously called the duck curve. You can kind of see why. In the middle of the day, the sun is blazing, and solar panels are just flooding the grid with way too much power. I mean, so much that it can cause major instability. A lot of that energy just gets thrown away. But then, the moment the sun goes down, everyone gets home, flips on their lights, their TVs, their everything, and demand just skyrockets. The grid has to somehow find a ton of power instantly. So the obvious answer to this problem seems pretty straightforward, right? Giant batteries. You'll hear them called BESS, or Battery Energy Storage Systems. The logic is simple. You use these giant power banks to soak up all that extra solar power at noon, and then you unleash it in the evening when everyone needs it. It smooths out those crazy peaks and valleys.
But here's the catch. Those batteries are incredibly expensive. I mean, eye-wateringly expensive. So that begs the question, what if there were another way? And this is where our unlikely hero enters the picture.
Now, this is the absolute key to this whole idea. The proposal says we need to stop thinking about Bitcoin mining as just this dumb thing that sucks up power. Instead, we should see it as a controllable load. What does that mean? It means it's a power user that you can turn off, on, up, or down with insane precision and speed. We're talking milliseconds.
So here's the mind shift. A mining operation isn't a battery. It doesn't store energy. Think of it more like a smart pressure release valve for the grid. When there's way too much solar power flooding the system at noon, you open the valve, and the miners just soak it all up. Then, when the grid is stressed in the evening, you slam that valve shut, instantly freeing up all that power for homes and businesses.
So you see, it's not about being a battery. It's about getting the same result as a battery. It's all about function over form. So let's get into the nitty-gritty of how it can actually pull off this impersonation act.
Okay, just look at this breakdown. To smooth out renewables, a battery has to charge up and then discharge. A miner just has to absorb the surplus. Done. For frequency regulation, which is basically keeping the grid's heartbeat stable, a battery can respond in milliseconds. Well, guess what? A miner can be shut off in milliseconds. Same result. And for peak shaving, handling that evening rush, a battery pushes power out to meet demand. A miner simply stops pulling power in. And here's the kicker. From the grid's point of view, reducing demand by 100 megawatts is the exact same as adding 100 megawatts of supply. It's a huge deal.
So if it can do a lot of the same jobs, the next big question is, why would you? Why bother with all this? Well, like most things in this world, the answer comes down to pure economics.
Let's put these two side by side. On one hand, batteries have a massive upfront cost. They physically wear out over time, and their whole job is to save you money by avoiding other costs. Now, on the other hand, you have a mining operation. It's got a lower capital cost for the same grid balancing power. The gear doesn't degrade in the same way, and get this, while it's helping the grid, it's also generating its own revenue by mining Bitcoin. It doesn't just save money, it makes money. And this isn't just some fantasy. There's a practical way to do this. A grid operator could pay miners a small fee just to be on call, like an insurance policy. Then when the grid operator needs them to soak up extra power, they could get a cut of the Bitcoin revenue that's generated. The secret sauce is plugging these miners directly into the grid's control system, so all of this happens automatically, in the blink of an eye.
Okay, I know what you're probably thinking. This sounds a little too good to be true, right? Well, you're not wrong to be skeptical. This is definitely not a silver bullet, and any serious proposal has to face the risks head-on. So let's get real for a second. First, a miner is a load. It's not a power plant. It can't power your city at night. So the idea isn't to replace batteries entirely. It's to use mining to dramatically shrink the size and cost of the batteries you still need. Then there's the wild volatility of Bitcoin's price. That's a huge risk. So you structure contracts around sharing revenue, not guaranteeing a price. And of course, the public and environmental concerns are massive. Any project like this would need super strict rules about where it can be built, total transparency, and a mandate to use only renewable power.
Because of all these risks and questions, nobody is saying we should just flip a switch on this tomorrow. You don't jump in head first. The logical, scientific, and just plain smart next step is to run a controlled test, a pilot program, to see if this whole idea actually works in the real world.
And the proposal is very specific. Start small with a 10-megawatt pilot project. That's big enough to give us real, meaningful data, but small enough to manage without risking the whole grid. You'd probably stick it right next to a giant solar farm so it can directly absorb that facility's wasted energy.
And a pilot program like this would have some crystal clear goals. You're not just hoping for the best. You're asking specific questions. Can you actually cut down on wasted solar power by more than 30%? Can these miners really respond to grid signals in under a second? And maybe the most important question of all, when you run the numbers, does this actually make financial sense? Does it save the grid money compared to just buying a bunch of giant batteries?
So we end up right back where we started, with this really provocative question. Is this idea a brilliant piece of engineering that could actually help us move to a greener future faster and cheaper? Or is it just a reckless plan to tie our critical infrastructure to one of the most volatile assets on the planet? We don't have the answer yet, but a pilot program could give us one. And that answer, whatever it is, will be a really big deal for the future of our power grid.